Good day everyone, I'm Kena Maritipa Diyos, one of the member of San Rafael Group, and this is our reporting. Moles, molar mass, and Avogadro's number, Chapter 4, the periodic table. Molar conversions.
What is the mole? The mole is the unit of measurement in chemistry. The mole is similar to other counting units such as 12 equal to 1 dozen. 1 mole of any substance contains 6.02 times 10, 23. Number of particles, Avogadro's number. How large is it? 1 mole of hockey pucks would equal to mass of the moon. 1 mole of basketballs would fill a bag of the size of the earth. 1 mole of pennies would cover the earth 1/4 mile deep. For example, 1 mole of carbon is equal to 6.02 times 1023 carbon molecules, since it has only 1 mole. Another example, if the mole of carbon is 2, we should multiply it into 6.02 times 1023. 2 times 6.02 times 1023 is equal to 12.04 times 1023.
Mass. It is defined as the mass in grams of 1 mole of a substance. Mass of 1 mole of an element or compound. Atomic mass tells the atomic mass units per atom or AMU, and unit of molar mass is grams per mole, and round to 2 decimal places. Converting grams to moles. For a single element, the molar mass is equivalent to its atomic weight multiplied by the molar mass constant 1 gram per mole. Here's some example of molar mass single elements. First, carbon. Carbon's atomic weight is 12.01 times the molar mass constant, which is 1 gram per mole, is equals to 12.01, and copy the unit gram per mole. Second, aluminum. Aluminum's atomic weight is 26.98 times 1 gram per mole is equals to 26.98 gram per mole. Last, zinc. Zinc atomic weight is 65.39 times 1 gram per mole is equals to 65.39 gram per mole. For a compound, the molar mass is the sum of the atomic weights of each element in the compound multiplied by the molar mass constant 1 gram per mole. Here's some example of molar mass of compound elements. First example is water. Water's formula is H2O. We need to identify first the atomic mass of each element. Hydrogen 1.01, oxygen 16.00. Since the hydrogen has 2 atoms, we need to multiply this 2 atoms to hydrogen's atomic mass. 2 times 1.01 plus 16.00. 2 times 1.01 is equals to 2.02 plus 16.00 is equals to 18.02 times the molar mass constant 1 gram per mole is equals to 18.02 gram per mole. Last example, sodium chloride. Sodium chloride's formula is NaCl, and we need to identify first the atomic mass of each element. Sodium 22.99, chlorine 35.45. 22.99 plus 35.45 is equals to 58.44 times the molar mass constant 1 gram per mole is equals to 58.44, and copy the unit gram per mole.
I will explain another molar mass example. First is the sodium bicarbonate with the formula of NaHCO3. First step, we need to identify all the atomic mass number of each element. First is Na, which is sodium with 22.99 atomic mass number. H is hydrogen with 1.01 atomic mass number. C is carbon with 12.01 atomic mass number. And last is the O, which is oxygen with 16.00 atomic mass number. Second is we need to add all the atomic mass number. So 22.99 plus 1.01 plus 12.01, but the oxygen here has 3 atoms. So we need to multiply the 3 to its atomic mass number, which is 16.00. That equals to 84.01. 84.01 multiplied by the molar mass constant 1 gram per mole equals to 84.01 grams per mole. Another example is sucrose with a formula of C12H22O11. Again, we need to identify all the atomic mass number of each element. So C, which is carbon with 12.01 atomic mass number, H, which is hydrogen with 1.01 atomic mass number, O, which is oxygen with 16.00 atomic mass number. Second step is we need to add all this atomic mass number. But since C here has 12 atoms, so we need to multiply 12 to its atomic mass number, which is 12.01, and the hydrogen here has 22 atoms that we need to multiply to its atomic mass number, which is 1.01, and the oxygen here has 11 atoms that we need also to multiply to its atomic mass number, which is 16.00. So 12 multiply to 12.01 plus 22 multiplied to 1.01 plus 11 multiplied to 16.00, that equals to 342.34. 342.34 times molar mass constant 1 gram per mole equals to 342.34 grams per mole. So here's the molar mass conversions. From mass in grams or molar mass to moles with 6.02 times 1023 amount to number of particles, and number of particles back to moles and moles back to mass in grams or molar mass.
Here are some examples of molar conversion. First example, how many moles of carbon are in 26 grams of carbon? Way back to molar conversion, as you can see earlier, it says that from mass in grams to moles and moles to number particles. Since we already have the number of grams, which is 26 grams of carbon, and the question is how many moles of carbon in 26 grams of carbon. So we need to find the numbers of moles and 12.01 gram of carbon as a number of particles. Are you wondering where did we get the 12.01 grams of carbons? 12.01 grams of carbon, if you take a look in your periodic table, the number of mass of the carbon is 12.01 and multiply it into 1 gram per mole, so that we get 12.01 gram per mole. If you still remember the molar mass that explains earlier, we need to crush out these grams of carbon, and the only thing remain here is 1 mole of carbons. Since we crush out the grams of carbons, 12.01 is still remain here, and also 26 is still remain here. So 26 times 1 mole of carbon is equals to 26 mole of carbon divided by, we will divide it into 12.01. So this is now the answer, 2.2 mole of carbon. The second question is, how many molecules are in 2.50 moles of C12H22O11? So 2.50 moles as mass in grams, and since we need to find the molecules, so we need to write 6.02 times 10 raised to 23 molecules here and over 1 mole. Now that we crush out now the moles, 1 is still remain here and 2.50 is still remain here. So 2.50 times 6.02 times 10 raised to 23, we will get now. And now we get 1.51 times 10 raised to 24 molecules. So C12H22O11 has 1.51 times 10 raised to 24 molecules. This is the third example of molar conversion. This example is easiest than those other example that I explained earlier. So this example, what you need to do is you will multiply this 2.50 mole to 342 grams. So that and divide it into 1 mole. So mole, you need to scratch this and this to get the grams. So the and the next thing you do is multiply this 2.50 to 342 grams and you will get 855.85 grams. So C8, C12, H22, O11 has 855.85 grams. Oh, that's all, and that's the final answer. The last example is find the mass of 2.1 times 10 raised to 24 molecules of NaHCO3. So 2.1 times 10 raised to 24 molecules times 1 mole times 84.01 grams over 6.02 times 10 raised to 23 molecules times 1 mole. So, what you need to do is, just like what I said, you need to multiply this 2.1 times 10 raised to 24 to 1 mole and to 84.01. So, before we multiply it, we need to crush this out, these molecules, and then another this 1 mole. So, the thing that remain is 2.1 times 10 raised to 24 and 84.01 grams and 6.02 times 10 raised to 23. So 2.1 times 10 raised to 24, multiply it into 84.01 grams and divide it into 6.02 times 10 raised to 23, and you will get the answer, and the answer is 293.06 grams NaHCO3. So this is now the final answer.